Hi, my name is Lauren Sullivan, and I'm an assistant professor at the University of Missouri. So I'm really interested in plant dispersal, and when seeds and pollen move around, this is how we get new individuals and genes into new habitats. So it's, dispersal is really important for maintaining biodiversity. However, despite the importance of dispersal, it's actually pretty hard to study and not a lot of people really want to do it. So what I'm interested in sort of in general is trying to understand more about how different global change factors like disturbance or nutrient additions or climate, they affect the process of dispersal, and then what that means for the resultant plant populations and communities. So I combine theory and experiments to understand more about how dispersal shapes plant populations and communities. And this sort of combo of theory and experiments is really important for studying dispersal because it's really difficult to capture seeds. And so this theory and experiments provide a really powerful approach. And so what I do is I create models that help us understand how dispersal might alter systems, and then go out and test these with experiments. And in the same vein, also collect field data on dispersal and plug these into predictive models to try to understand the consequences of this dispersal for both plant populations and communities. And so one of the really exciting experiments that we're working on now is to try to just get basic information on seed rain in grasslands, right? So we don't really know a whole lot about it. So what we're doing is we're putting out these AstroTurf seed carpets and basically stapling fake grass to real grass, seeing what seeds fall on them, and then using that to try to make predictions about how communities assemble naturally. And so I'm really excited to sort of take all of the dispersal trait information that I have from Cedar Creek and apply it to, who's landing where, and make bigger predictions about how this process of dispersal influences plant populations and communities in some of the longer term succession experiments at Cedar Creek. I have done a lot of work sort of teaching in collaboration with Cedar Creek, teaching some 7th grade students how to understand the scientific process and the scientific method. And everything that I've learned from those experiences that I did for several years have been instrumental in helping me develop my own teaching program here at the University of Missouri, as well as outreach programs. So yeah, I'm very thankful for Cedar Creek for those experiences.